Hi, we're back, and in this one, we're going to get started on coding one of my favorite things, which is Blackjack. And as you can see from our public interface, class diagram, hybrid thing we got going on here, there's lots of classes, and there's some interaction going on here, and it looks like there's a lot of methods, but realities are this is going to be pretty logical. These objects are actually going to make things kind of easy. Relative to doing it with arrays and not doing objects. I had a student I was talking to today that did Blackjack last year in computer science principles as his end of year project for the college board, and said he had over 700 lines of code in order to achieve this. We're going to do this in a lot less lines of code thanks to objects, thanks to array lists. Let me show you the end result. So I'm going to run my driver real fast. You'll see just real quick, this has 4 players in our Blackjack game, but we're creating Blackjack here, and we have bet set to 5. Effectively, the bet is set for the table, so every hand of Blackjack that gets played is worth $5. That's a lot better than asking the players each round, how much are you betting this round, right? Which is something that we kind of did with Lucky Sevens in the past. And this is also true to kind of real life. Usually the Blackjack table itself has a hand price, and that is what it is. Okay, I'm also going to give all the players $30 to start out with, and you see we have our 4 Ninja Turtles that are going to be participating in Blackjack. I'd like you to take a real quick look at the way that they are added, right? Leonardo is added first, but you actually see that it's Michelangelo's turn that's going to go first. More on that little nuance much later. But we see a new round has started. We see the cards of everybody. And we see one of the dealer's cards. If you don't know how to play Blackjack, pause, go figure out how to play. I don't want to cover all the nuances here on how to play the game, but this should be pretty much fully functional despite just being text-based. You also notice one neat feature is we've managed to get the actual symbols here for our cards. We will do that. We actually will do that today in this video. But Michelangelo has a 17 currently, Donatello a 20, Raphael is 7, Leonardo is 16, and the dealer is showing it too. It's Michelangelo's turn, and he is presented with these 3 options. Could hit, stand, or double down with the 17. And let's say that Michelangelo chooses to stand. So we'll stop with that final value of 17. Donatello has 20, given the option to double down, which should not actually always be there. You don't always have the option. I guess you do always have the option to double down. I'm thinking of the other thing. We're going to stand on that 20. Raphael's turn, 7. Definitely want to hit on that, so we will hit up to 11. Notice that the option to double down has disappeared. We will hit on that. And Raphael hit exactly 21. Our game actually stopped in there. Said you don't want to go any further automatically. Finally, we're left with Leonardo's turn. 16 is rough. Why don't we try hitting? So ultimately, all 4 players ended up going. Leonardo busted, poor guy. But then it was the dealer's turn. The unrevealed card turned out to be a 10. The dealer basically has AI it's super easy, that'll tell it to continuously hit, basically until we hit like 17 or bust or something. We ultimately busted here at 25, and we see the final winnings, right? These 3 fellas managed to stick around in the game, so they earned $10, doubled their money. Leonardo unfortunately busted. The dealer also busted and received negative money. This is just kind of to keep up with how much money the dealer has lost, kind of just for information at the end of the game. But this is Blackjack, and it's actually fully functional. There's a 4th option that we don't see here, which is when the 2 cards are the same value. But we will code every bit of this, starting with our card class. So if I flip back, right, we see that card has a constructor where it takes in 2 integers. These actually correspond with the suit and rank of the card, right? We actually see getters here for both of those things. We're going to represent these things with integers. There's multiple ways that you go about doing this. Like, it's going to get translated inside of the card class itself into appropriate strings. But by using integers, it actually makes it easy to create a whole deck, right? Because we can create loops and basically go through every numeric version of the card, right? Like the two of spades could just be represented numerically with a pair of integers. We're going to have get value. It's slightly different from the suit because the thing is, the value of a card in blackjack, 2 to 10, it's just the value that's there. Whatever, I'm sorry, it's based on the rank, right? So 2 to 10, whatever the rank is, that's what the value is. But once you get to the face cards, your jack, queen, king, those are worth 10, so the value is actually different. And then once again, once you get to an ace, that is a 11 or 1 depending. We'll handle that as well. We see our 2-string, and that's going to be a good starting point, is this card object. In IntelliJ, I'm going to create a new project by going to File, New Project. We'll go next, and I need to switch folders here. Going to select my AP Computer Science A folder, and we're going to call this project Blackjack. I'm going to put it in a new window. That's only because I don't want to lose this guy here. Right? I'm going to drag him over to the other screen so I can refer to him. He's already Java docked, all that jazz. So we're going to make a new Java class here. I'm going to call it card. Okay. Ultimately, a card has 2 things, like a rank and a suit. Again, there's multiple ways you could represent those things. You could use characters. You could use strings. I highly recommend integers, and then you kind of translate it inside of the card. Otherwise, you're looking at translating it some other place, like maybe a method in card, right? You got to take that integer and change it into what you actually need. So we're going to create a pair of integers, 1 for the rank, 1 for the suit. The moment that we have our instance variables, we can go ahead and start auto-generating code. So I'm going to Alt-insert a constructor. It's going to ask me what instance variables. I can Shift-click or Control-click in order to get both of these. And there is our constructor. Okay. Realities are I'm just going to let those numbers kind of sit in the card, and the actual translating happens whenever we basically do the 2-string or we get the value, something of that nature. I'm also going to go ahead and Alt-insert a getter just for the rank. I have one in suit for my completed code. It's grayed out, meaning I didn't use it in the entirety of the project. What we ultimately care about whenever we're talking about this is get value. So public int get value. Again, value is slightly different from rank. They're pretty much the same thing, but the difference being whenever we get to those face cards, the value changes. Let's Java dock this thing. Right? We are going to return the blackjack value of this card. Things in the 2 to 10 range, it's just whatever the rank is, right? You're going to get back a 2 to 10. Maybe a better way of saying this is if it's 2 to 10, what you're getting back is rank. That's literally this instance variable. If it is a jack to king, what you're getting back is a value of 10. Ace is a little tricky, right? You could choose a 1. Realities are ace defaults to like an 11, and then you change it when you need to. As it turns out, like when you're playing blackjack, you can choose the value in ace at a 1 or 11, but the decision point on when to switch it from a 1 or switch it from an 11 to a 1 is like those scenarios are pretty niche and just like self-explanatory to the point that we'll convert it when we need to, which is when we're valuing the total hand. We want to know what is the total value of the hand. That's when we can determine, should we treat the ace as an 11? Should we treat it as a 1? My recommendation is let's treat it as an 11, and we'll worry about treating it as a 1 later. So let's finish out the logic for this. Right, this is going to be based on rank, and rank is ultimately a number. Right, this 2 through 10, that should be pretty easy. Whenever this method is called on the card, all we got to ask is if rank is less than or equal to 10. Right? I shouldn't really have a negative rank. I really shouldn't have a rank of 0 or 1. That would be something that we would end up Java docking up here, right? We would maybe put in a precondition that rank is going to be effectively, well, 2 is my smallest, right? So rank is going to be in this range 2 up to, well, if I'm going to basically give each of the ranks, right, we're talking about these, the face value of the card, 2 through ace. This is a 10. The jack is an 11, the queen a 12, the king a 13, ace is a 14. Right? Make sure I did that right. 10, 11, 12, 13, 14. So rank can be in that range. 2 to 14. We'll come back to the suit. Actually, I'm already here. Let's do it. All right, suits, there's 4 of those, right? You could choose basically 1 through 3 if you want. I'm sorry, 1 through 4 if you wanted. It's easy enough, and it kind of doesn't matter. I'm going to choose 0. That's going to make our loops a little bit cleaner, more what we're used to later on. Again, we're going to ultimately use loops in order to generate like a whole deck of cards. So 0 makes a little bit more sense. Rank is going to be in this range, 2 to 14, inclusive on both ends. Suit is going to be 0 to 3, inclusive on both ends. I say all this to say that whenever I get down here to get value, I can just check to see, is the rank less than or equal to 10? I don't have to worry about negative numbers. I don't have to worry about 0 or 1 for rank. This is basically guaranteeing that that is something I don't have to check for. That is the beauty of preconditions. If rank is less than or equal to 10, I can just simply return whatever that rank is. If we're still here, right? I could basically check for the ace is actually the next easiest thing to do. If rank is exactly, let's think about this. What would an ace be for us? An ace would be a 14. So if the rank is exactly a 14, I'm going to return exactly 11. For all other cases, we're talking about this jack through queen. I'm going to return a 10. Okay, and of course the order here can kind of vary depending on how you want to check it. But I went with what was actually kind of the easiest to code. So here's our GetValue method. In order to test all of this, I'm going to need a string, right? A 2-string to kind of see this. We can call GetValue. We can call GetRank. Really, that 2-string is going to make things super clean. So public string 2-string. And I say all this because I want to visually see the card. Right? We're going to ultimately return a string representation of this card in the format rank suit. Right? And by rank suit, I'm literally referring to these instance variables. Rank, no space, suit. Okay, examples. Right? We're talking the ace of hearts or the king of diamonds. Right? The 10 of spades. We're going to plug these things in just a moment, that moment being right now. So with this, you got to keep in mind that our rank and our suit, they're stored as integers. But here, what I'm ultimately talking about, these are basically strings, right? This is a number, so that integer seems pretty easy, but this is not a number. This is very much so a character, a part of a string. So we got to do some translating. That translating can happen right here in the 2-string. Same thing with these things. These are definitely not numbers. So I have to translate the integer for the suit into a character, into a string in order to do all this. Okay, I'm going to show you something super big brain with doing this translation. I'm going to create a string array, and I'm going to call that ranks. Okay, hear me out. Here are the ranks that we need, and they correspond with something else, right? 2 through 10 doesn't really correspond with anything else, but once I get to 11, that's actually a jack. I'm going to create an array, and I'm going to initialize it here on this spot, okay? We don't always initialize outside of the constructor. You could simply initialize this in the constructor. I'm doing it here as opposed to in the toString, which is where I ultimately need it, because every time we call the toString, we'd be making this over and over and over again. Realities are you would want this to be like static, not super important. I'm going to store the ranks. What do I mean? I need to basically translate this integer into something else. Well, as it turns out, indexes are integers. Check out this logic. For index 0 and index 1, I got nothing. They're actually unimportant, right? I'm never even going to use these because I know my rank is not even going to be a 0 or 1, but I do need to fill up these spots. When we get to rank 2 and rank 3, we're basically keeping those the same, right? When I get the element at index 2, that is the rank, I'm going to basically get 2 back. Now, this seems kind of pointless. Why are you doing this? Well, if we keep going with this, right, I fill out the rest of this string array. It really starts to shine when we get past 10. Right, here I am at 10. 10 appears at index 10, right? This is index 0, index 1. So at index 11, it's not the number 11, but it's Jack. What does that mean? This is basically a map or a dictionary, but I can take 11, the rank, go into my ranks array, and see what is there. In this case, it is a Jack, and that is effectively my translation. I mean, the other alternative to this is like you set up like if statements, checking what is this saying exactly and translating it on the spot. Right? 12 is a queen. 13 is a king, and my rank 14 is not a 14, it's an ace. We're going to do something similar for our suits. Okay, I have 4 suits, so when I'm done, this suits array is going to have a length of 4. What I want to do is take the number 0 and translate it into a heart. Okay, these are special characters, and for me on a Windows machine, I don't know if it's going to be different on a Mac, maybe not. It is Alt, and then the keypad 3. Okay, I'm not talking about the numbers at the top with your letters. I'm talking off to the side, that keypad 3. Right, that is a heart. Keypad 4 is a diamond. Alt and keypad 5 is a club. Alt and keypad 6 is a spade. Right, this is like a perfect comment. So Alt plus keypad 3 is going to give you a heart. But I'm going to kind of represent this as a range. Alt and keypad 3 through keypad 6 will give you these symbols. That's what this comment means. Okay. If you're unable to get these bad boys, you might be able just to Google and then copy and paste them here and roll with that. So I've set these up. These basically exist for translating. Right? If the rank is if the suit is a 0, I'm going to go into the suits array at index 0, and what that actually is a heart. Again, the alternative to this is like a bunch of if statements or a switch statement, if you know what that is. And this is way cleaner than both of those things. I'm putting it in the card object itself as opposed to creating these arrays in the toString, because this gets created wherever the card is created, as opposed to creating it and destroying it every time the 2 string is called. Minor efficiency thing, but this makes this super easy. I'm going to, at the point of return, right, I want the rank. So I'm going to go into my ranks array at position rank. Okay, let's maybe get a for instance. An ace of hearts is effectively a rank 14 with a 0 suit. So I'm going to go into ranks at rank 14, right? We're going to go up here to this array. This is index 14. That's an A. So this is an A. Plus suits at suit. I'm going to go into my suits array at index 0. That's a heart. So we're going to do A plus heart, and that is going to be our ace of hearts. Let's try this out real fast in a driver. I'm going to create a new card. Right? As we just talked about, an ace of hearts is a 14-0. Right? Keep in mind that whenever we're creating a card, we express it in terms of the integers. That may seem wild to you right now. You know, why not just do strings here? This is going to make it easier later on whenever we have to create an entire deck of cards, and we can just use integers to basically go through every possible combination. So this should be an ace of hearts. I'm going to see. I'm going to right click, tell it to run my driver. And there it is. Right? If I try some other situation, 12-3. Nice. One last one. What about like a 7-2? Notice I'm not doing a 4 here, right? That would give me a problem. That apparently is a 7 of clubs. Okay, but what if I asked what is the value of that card? In the case of the numeric ranks, it should just be whatever the rank is. Right, the value of my 7 of clubs should just be a 7. But if this were a jack, right, the rank is an 11. The GetValue method should give me back a 10 because that is the blackjack value of that. Same thing with a queen and a king. But if we were to do an ace, the value of that should be an 11. Beautiful. Yeah, let's look at what we got left for a card. All right, we got our rank, we got our value, we have our 2 string, and I told you we don't need a suit. Right? I made it, but I never ended up using it. Okay. I'm actually thinking I'm going to pause the video here, right, at 22 minutes. This is a good stopping point for our card. I'll give you one last look, and then I'll see you in the next one.